All right, guys. So we're going to do our last set of notes for this unit. Tomorrow we're going to do a review-like thing. Monday we're going to do a lab, which will also help you review, but it's a lab over reactions, the last one. And then Tuesday we'll do official review, Wednesday test. It's kind of our plan for this unit, almost over. So last set is 32B. There we go. There we go. So we're on 32B. Now, I guess I'll sit for a second before I start writing. So yesterday we focused on just single replacement reactions. That's it. Today we focus on double replacement reactions. So we're going to break it down as to when does a double replacement reaction actually occur. Okay. Not every time that I put two compounds together do they just always swap partners. That only happens when it would be more beneficial for them to swap. So there's only a couple circumstances where they would. When that happens, the three driving forces for a double replacement reaction are the formation of a precipitate. So it's more like they want to be a solid, they want to become a precipitate. So a precipitate is a solid formed during a chemical reaction. So when a double replacement reaction happens, it's with two liquid compounds. So they do have to be liquefied first. After they're liquid and you mix them, if the mixture, the chemical reaction would form a precipitate, so one of the products of the reaction would be a solid, so two liquids making one solid, then that's beneficial to the reaction and the reaction will occur. So what we have to know is when will a reaction make a solid? If it will, then the reaction will occur. If the mixture does not make a precipitate, then the reaction won't occur. How do you know if a precipitate will be formed is if it's soluble or not. So you see this soluble, insoluble. We can know if it's going to be soluble by looking at your solubility chart. So like yesterday you had to look at a chart, today you have to look at a chart to know if it's going to work. So this is your solubility chart, okay? So I have to go back and forth between this one today. I'm yawning. I wasn't yawning earlier. So my solubility chart has soluble compounds over here. So when these are in a compound, they are always soluble. So there are no exceptions. They're always soluble. Now you have a couple down here, starting with bromine, chlorine, iodine, and sulfate. They are usually soluble when mixed with when bonded with a metal. They're usually soluble, which means like soluble in water. But there are a couple types of things, a couple metals they could be with in a compound that actually wouldn't be soluble. So that's what we're looking for is a precipitate. Because if it's soluble, it dissolves, it stays a liquid, okay? We're looking for when it's not soluble. So when it's not soluble, that means it won't dissolve, so it's a solid. So it's making a solid, which is a precipitate. So it's making a precipitate when it's solid, okay? So when it's not soluble or insoluble, it'll be this whole list. All these guys are insoluble. They're not going to dissolve. They're always going to make precipitates, except with these couple things. So NH4, which is ammonium. So all of them are soluble when bonded with that. And when they're with the alkali metals. The alkali metals are the first metals in the periodic table, the first column. I'm going to go write those down first. When they're mixed with those, they are soluble. So if I go down my periodic table list, that'd be, why is it always uncalibrated? I don't understand. And now, even after I do this, it's uncalibrated. See again. All right, so Li, there we go. Sodium, then potassium, then rubidium. You're really not going to see cesium or francium. They're on the first row, and if they did bond, it would be soluble. So that means these are always insoluble, except when they're a compound with ammonium or one of those metals. That's like all those metals. That would make it not a precipitate. And then a couple of these down here have ammonium and the alkali metals and calcium, strontium, barium. So it has the same thing, ammonium has all those alkali metals and calcium, strontium, and barium. Okay. All right, now let's scroll up and try to figure out how to write this reaction. They also usually form a gas or formation of molecular compounds such as water. So determine whether the following are insoluble. So if they're not soluble, then they're solid, then it's a precipitate. Or if they are soluble, which means it doesn't form a precipitate. So that's all we're gonna do is tell me is it soluble or insoluble, and then tell me if it forms a precipitate, okay? Now, is this gonna let me write? Oh, cool. All right, so sodium and chlorine. Now you're always looking for the second one. You're always looking for the non-metal, okay? So we're looking for those. So I'm gonna look for chlorine and I'm gonna see if it's soluble with Na, which is sodium. So I go down, I'm gonna find chlorine. Chlorine is right here on the soluble list. So it's usually soluble. It does have a couple exceptions though. It's not soluble with Ag, Pb, or Hg. Well, that's not Na, so that means it is soluble. Okay, so here we'll put, erase. Why wanted to let me go there. All right, so it is soluble. All right, spell soluble. Oh, there's no A. I was like, why does that look weird? There we go. Soluble. Now, if it is soluble, then it doesn't form a precipitate. Because remember, a precipitate is a solid. So if it's soluble, that means it's dissolving. It's a liquid. So it's not a precipitate. So that wouldn't be a precipitate. Now for AgCl, so same thing. We're looking for chlorine and see if it's soluble with Ag. So look, same thing. Chlorine's usually soluble, but it's not soluble with Ag, which is what this is. So it's with that. So that would be insoluble, like that. Able again, okay, like that. Insoluble. Now, if it's insoluble, then yes, it would be a precipitate, which means double replacement reaction would work if it was making that compound. All right, let's look at the next one. So we're looking for PO4. So PO4. Going down, not seeing it. PO4 is in the insoluble list, means it's usually insoluble, but it is soluble with ammonium, which is NH4, and alkali metals. So ammonium is that NH4. So yes, it is soluble. So it's usually not, but it is soluble with NH4. So I'm going to put soluble. And over here, it'd be a no. Okay. Now BaSO4. So SO4 is on the soluble list, so it's usually soluble, but it's not soluble with strontium, barium, lead, and mercury. So go back up. And right now, SO4 is with barium, which is one of its insoluble things. So it's not dissolvable when it's mixed with that compound. So it's insoluble. Remember, insoluble means, yes, it's a precipitate. It would precipitate out and be a solid out of those two liquids that mixed. All right, nitrate. Now, nitrate is one that you should start noticing. That's NO3. Nitrate is at the top where it's soluble and it's always soluble. So there's literally nothing to be mixed with. It's soluble. So if you start noticing some of these that don't have exceptions, then like you can kind of quit looking. So ammonium, always soluble. This acetate, sometimes written like this or this, but that's acetate, and cyanide, and then all the types of chlorine. So that'd be, what was it? This one would be perchlorate, chlorate, chlorite. I can't remember what the one's called. Okay, but all the chlorine ones with oxygen are always soluble. So up here, definitely always soluble. If it's soluble, then it's not a precipitate. So that part, easy peasy. Okay. Now, examples, AlCl3 plus AgNO3. So if I'm going to write this reaction, I need to know if it's going to form a precipitate. So remember, a double replacement reaction are going to swap partners. So the aluminum is a metal. So it's going to change its nonmetal partner and pick the other nonmetal. So it's going to be Al with NO. You know what? I probably have to write through like that. Okay. And then I'm just going to kind of draw it out, put a plus sign, and Ag is going to switch partners and go with chlorine. Ag and chlorine. Now, one of those is a precipitate, and I want us to mark which one is a precipitate. So AgCl, so I'm going to look at chlorine. Chlorine, remember, is not soluble with Ag. So that's our precipitate. NO3, aluminum nitrate, remember NO3 is the one that's always soluble. So that's not our precipitate. But this reaction would occur, and it would have AgCl as a precipitate. So I'm going to go right on that up here. That'd be a little easier. So remember, when I have a compound, I do have to balance it. So aluminum is a +3, nitrate is a -1, so that 3 does have to come down. So it's really going to be AlNO3 with a 3 outside it, like that. Ag is +1 and chlorine is -1, so those balance 1 to 1. So we'll say like this. But this one we'll label as our precipitate. I'm pretty sure your worksheet asks you to label which one is the precipitate. So it's the one that is insoluble. Okay. Now, this will be easier for you to skip here. So a yellow precipitate is formed. So it's telling me it works. It forms a precipitate when an aqueous, that just means dissolved in water, solution of potassium chromate. Okay, so let's start there. Potassium is K. Chromate is CrO4 and has a -2 charge. I do have that memorized in my own head, but you would just go look it up. Okay, so chromate, remember, it's an agent I. It's a polyatomic ion. You go look it up. And it's CrO4 with a -2 charge. Potassium is in the first column on the periodic table, so it has a +1. So that 2 is going to have to cross down, like so. So if I write it again, I got K2CrO4. Okay. So potassium chromate is mixed. So that's when we put our plus sign. It's mixed with an aqueous solution of lead 2 nitrate. So if I have lead 2 nitrate, so that'd be Pb with a +2. So that's what that 2 means. And then nitrate is NO3 because it ends in H and I, so it's polyatomic ion. Nitrate has a -1 charge. You can know that by Googling it or looking at your polyatomic ion list. So the 1 will come down and the 2 will come down. So I got to put my parentheses around it. So how it looks officially, Pb, NO3 with a 2. Now, it's already said it formed precipitate, so I know what's going to happen. I just need to write it. So when I swap these compounds around, remember metals go with the nonmetals. So the K with NO3 and Pb with CrO4. So I'll write that out. K with NO3 and Pb. Let's put like P and B together for some reason. Rewrite all that. Okay, so K NO3 plus Pb KrO4. Now, same thing. We want to know which one is the precipitate and label it. And I want to make sure their charges are balanced. So potassium +1, nitrate's still a -1. So those are balanced 1 to 1. And so we already did the charges on the other side, so I just need to look at them. Pb is still a +2, and chromate is still a -2. Oh, look, okay, they're balanced. No numbers need to come down. So this is how it would look, KNO3 plus PbCl4. But I want to know which one is the precipitate. So if I scroll down, I'll let you do that. Okay, so look. Remember, NO3 is soluble all the time. So I know it's not that one. It's not KNO3. If I keep going down to find chromate, CrO4 is in the insoluble list. It's insoluble all the time except NH4 or alkali metals. Remember, your alkali metals are Li, Na, K, Rb, and Cs, all ones in the first column, and Pb is not that. So it is insoluble. Okay. So if it's my insoluble one, then it's my precipitate. The one that isn't soluble is my precipitate. All right, there we go. So that is our last set of notes for this unit.